Okay. Yeah, in the last class, what we discussed in the last class, we seen about the constraint, no, constraint and randomization. Just so we discussed about this constraint and randomization. Okay. Mm, so what we discussed, this is constraints. So that means we are giving the data with some condition. Those are nothing but constraints. Okay. We already seen the syntax and rand mode also we already seen. So random mode means this is the syntax like constraints, identifier and constraint expression. Okay, rand width. Okay, constraint range is less than 4. Okay, random mode means what? If you want to turn off the randomization, we can use this handle dot rand underscore mode. And if you want to turn on this randomization, we are using this handle dot rand dot mode. Okay, constraint mode means this is going to control the constraints. Okay, so if you want to turn off, we can use handle dot constraint underscore mode, and this is handle dot constraint underscore mode. This is turning on, and this is inline constraints also we already discussed. And so inline is nothing but these are applied when we are calling the randomized methods, and inheritance also we seen. That means we can write this okay, parent class and child class we can use in the constraints. Okay, uh, and constraints with conflicts also we already seen. Okay, so this is constraints is very important topic. Some more topics are there, and so we'll discuss the topics, and so that next top and tomorrow we'll see the next topics. So if you see this first, so we'll see the distribution constraints. Okay, so this is a distribution constraint. Yeah, distribution constraints. Distribution constraints. Okay, distribution constraints. So what are these distribution constraint means? This is we are using a keyword called keyword, that is dist. We are using a keyword called dist. Okay, so class test, rand rand int data. Okay, we'll see one example about with this distributive function. This is I'm writing constraint range. Okay, range. I'm giving this data dist. Okay, I'm using a keyword called dist, and here this 7 colon that is equal to 5. Okay, uh, comma, and 11 is to 20, 11 is to 20 colon equal to 3. Okay, and 25 is to 30. Okay, colon 30 and colon oblique 10. Okay, semicolon will be inside the flower bracket, and this is the basic syntax, means basic example. We say the example for this distributed constraint. Okay, so what is this? So step by step we'll see what is this. Okay, first what is this? 7 is to 7 colon equal to 5. Okay, this is nothing but weight. This is nothing but weight. Okay, so weight means how many times 7 should be repeated. Okay, so this shows that how many times, okay, weight, how many times this 7 should be repeated. Okay, 7 should be repeated. Okay, so here if you see, so this is weight means what? 7 should be repeated for how many times? 5 times it will be repeated. Okay, so I can use like a colon that is equal to. Okay, what is this? This is equal distribution operator. So what is this? This is equal distribution distribution operator. Okay, equal distribution operator. Okay, and next next you see. So next in this you have next one is you have 11 colon 20 is there, no? So 11 colon 20, that is equal to 3. Okay, so 11 colon 20 means here from 11 to 20 how many values are there? 10 values are there. Okay, 11 to 20, you have 10 values. Okay, so that means 11 is nothing but, so this is weight of 3. So that means 11, this is weight of 3 means 11 should be repeated for 3 number of times. Okay, similarly 12 should be repeated for 3 number of times. Okay, this is repeated for repeated for, this is nothing but weight. Okay, this is nothing but my weight. How many times it should be repeated? Okay, it should be repeated for 3 number of times. Okay, similarly 13 should be repeated for 3 number of times. Okay, and up to so on 14 should be repeated like that. 20 up to 20 it should be repeated for 3 number of times. Okay, so this is what this one. Okay, this one is 11 colon 20, that is colon equal to 3. Okay, and next is if you see next one, one more, this one if you see 25 is to colon 30, 25 colon 30 colon oblique 10. Okay, so what is this, in this how many values are there? 5 values are there. So that means 10 by 5. 10 by 5 means how much you are getting? 2, no? So 2 means this is nothing but basically weight. Okay, so this is nothing but weight. Okay, this is weight. So means 25 weight of 2. So 25 weight of 2. So 25 weight of 2 means what? It should be repeated for how many number of times? So this should be repeated for 2 times. Okay, and similarly 26 should be repeated for 2 times. Okay, 26 should be repeated for 2 times, 27 should be repeated for 2 times. Okay, up to so on 30 should be repeated for 2 times. 30 should be repeated for two times. Okay, so this one we need to execute in our tool. Okay, write the program related to this distribution constraints. Okay, you can consider this as a weekend assignment also. Okay, so if you are not getting, we'll discuss in the next class. This is one, assignment one. Okay, so you need to write the program related to the distributed constraints. Okay, distribution constraints. Okay, so this is distribution constraints, and next is conditional constraints. We'll see the conditional constraints. What are these conditional constraints? Okay, mm, so conditional constraints. So conditional constraints. So like first one, this is constraints. Constraint. I'm using a identifier, const underscore identifier, and this is some expression. Okay, expression, and this this is constraint set. Constraint set. Constraint set. Okay, and here this will be so flower bracket will be closed. Okay, this we'll discuss later. Okay, we'll discuss later when we are going to further topics. Okay, now we discuss this conditional constraint means it is like if else statements also, like if underscore else is there. Okay, if else statement we got in C and this Verilog, no. So what is that? Constraint under constraint identifier. What is my identifier? Constraint underscore name, and this is one example. If expression, what is this constraint underscore set. So if condition is satisfying, if expression, so constraint underscore set, else constraint underscore set. Okay, let us take this is set 1 and this is set 2. Okay, this is set 2, and close this. Okay, so you can use this symbol also. This is a hyphen greater than. You can use this symbol also. Okay. So example like we can use constraint, constraint tag, constraint tag, and mode equal to one tick binary one. Uh, so this is colon greater than data is less than 5. Data is less than 5. Okay. And mode equal to one tick binary 0, data greater than 5. Data greater than 5. Okay. And close this bracket. Okay. So this is by using this operator. Okay. This operator. Okay. Uh, by using if else means you can write like this also. So if else, if underscore else. Okay. If else, how we can write a constraint, constraint mm, tag, tag. Uh, if same program, I can write like this also by using if else statement. Okay. If mode equal to 1, data is what greater than 5. Data is greater than 5. Else if, else if mode equal to 0, data is less than 5. Data is less than 5. Okay. Close this. Okay. So this is also you need to write the program related to this conditional constraints. Okay, try the program in the tool and you write the program in GVim and try the program in tool or EDA playground. Okay, so this is assignment two. Assignment two. Okay, assignment one is distributed constraints and assignment two is a conditional constraints. Okay, and static constraints. Okay, we'll see the static constraints. What are the static constraints? Okay, so static constraints. So if you see the static constraints, let us take static constraints. Okay, static constraints. Uh, let us take one example. Suppose class test. Okay, uh, so rand. I'm using randomized keyword rand into data Okay, so static constraints constraint valid underscore data valid underscore data. So this is data greater than 10. Data greater than 10. Okay, and end class. Okay, this is the property and I'm writing the constraints and begin initial begin. I'm using two handles. So I'm writing for the handle test t underscore t1 underscore h t2 underscore h. Okay, and next you need to write the methods. Okay, methods are functions. Okay, so methods are we can write the functions. Okay, so how I can write t1 underscore h equal to what new. So I need to create the object for this handle. Okay, so t2 underscore h equal to what new. Okay, and next what I am doing uh, t1 underscore h. Okay, t1 underscore h dot randomize. Okay, randomize. Next t1 underscore h dot constraint underscore mode of 0. Okay, of 0. Okay, so this example I wrote, one second I will show you. So constraints, one second. So here if you see db core dbm, one second, sv. Okay, this is dbm. Okay, constraint 2. this is static constraints. Okay. So if you see this, so so class test randint data, and here what I am doing means so here this one I will comment this. I want to see these values. Okay. So that means constraint range data is greater than 10. Okay. Here, this one I am giving data less than 10. No? Okay. Data less than 10. And I want to check all these conditions. So data is greater than 10 and end class module TB static constraints. And I'm writing for the handle initial begin. And with the help of this handle, I'm creating the object. Okay, and I'm repeating for how many times? I'm repeating for repeating for 5 times. Okay, so repeating for 5 times, and I'm with the help of this handle, I'm using this t underscore h1 dot randomize this function. Okay, so or I'm writing this method. Okay, and I want to display this value. The value of data is a percentage d t underscore h1 dot data. Okay, so this one is there, no? So this one I will execute. So I'm saying this. I'll execute in the tool and I will show you. See here. I'm opening this Quasta sim. So where is my file? Here, this constraints, no? So constraint means okay. Before this, I need to create this two files. What are those files? Here I need to create one. One is a TB file, okay, and next one is sim file, simulation file, okay. Sim file I need to create, okay, simulation file, and whatever these are not required. So whatever these files are there, just I'm saving in TB file. Okay, Control C, Control X, and I'm saving this. Okay, here if you observe here, so this one that means this file name. So this TB underscore static underscore constraints and this file name should be same. Okay, it should be same. Okay, and so I explain this program. No, so here this is sim file. No, sim file. So just you copy this path. You copy this path. Okay, go to Quasta sim and in transcription window cd space. Okay, you copy that file. Okay, okay. So so it will go. Ls means what? It will show this whatever the files are there. Okay. So nothing is there. It is not showing anything. Okay, list file. Okay. Next entity. Next means next is uh, VLib. I need to create the library function. No, VLib work. VLib work. And next vmap work function is created, and next vmap work. I need to map the work function. Okay, so my work function is mapped. Okay, and next I need to compile this code. Vlog. What is my file name? What is my file name here? TB underscore constraints. No, so my file name is TB underscore constraints. Okay, vlog vlog dot underscore tb forward slash. What is my function? This is static underscore constraints dot sv. Okay, so just compile this. Okay, and one warning I got, just omit this. Here this one is there, no? So this one just you copy vsim vsim and control v test bench. Okay, vsim and this test bench file. Okay, vsim this test bench file. Okay, test bench file. And next, what you need to do, it will go into this same file, run minus all. Okay, run, one second, run minus all. Okay, see here, what you have got, the value of data is what in this program. What is my constraints? So, what is my constraints? That means, so constraints is greater than range is greater than 10. No, So here you got this value. The value of data is what you are getting greater than 10 only. Okay, you are getting it greater than 10 only. So like this, you can see this. Okay, and I'm changing this function. Suppose less than 10, I will keep. Okay, I will comment this, and next I will. So I want to see the data less than 10. Okay, I will save this and go to Costa Sim, quit sim, quit minus sim. Okay, it will come out of the loop, and here again we log this constraints, and next vsim this constraints. Okay, it will execute, and what is that? Run minus run hyphen all. Okay, so yeah, what you are getting the value of data is what less than 10 means you are getting the values less than 10 only. Some random values you are getting, and those values are minus values you are getting. Okay, and again, what I will do, I will comment this. Okay, I will comment this. I want to execute the constraints within this range. The constraint range is what the I want to. The constraint range is data is greater than 0 and data is less than 10. Okay, data is less than 10. Okay, so this one you save this. Again, go to Costa Sim and quit Sim. Okay, you need to come out of the sim, quit sim, and again you compile. Okay, if you apply this up and arrow, you'll get the commands. Okay, whatever the previous commands you pressed, that you will get. Okay, so we log this command. Okay, and vsim vsim. Okay, and next run minus all, run minus all. Okay, run hyphen all. So you observe here. So the data, the value of data is how much? So it is printing the random values between 0 to 10 only. Okay, it is printing the values from 0 to 10 only. Okay, so like this you can see the values between these different conditions. Okay, so different conditions you can see the constraints. Okay, this is like randomized constraints. Okay. Okay, so next program we'll see. Okay, what is that next program? Next program is yeah, see here. Mm, okay, yeah, TB. Okay, next let us take static constraints 2. Okay, so this is my program. Um, underscore 2. So if you see this program, so same thing, but here what I did means same class test ran into data, and I want to execute a constraint range from 0 to 10 and end class, and so this is the TB module Testbench function, Testbench name, and I'm creating the handle initial begin, and I'm creating the object and repeat for 5 times. Here what I'm doing means t underscore h1 dot randomize. Okay, that I'm so previously I have only one handle. Here I am creating two handles, t underscore h1 and t underscore h2. Okay, and here what I am doing means t underscore h1 dot constraints underscore mode I'm making as 0. Okay, so when you make as 0, so previously we already seen, no. So when you make as 0, that conditions I'm means just switching off. Okay, so whatever the conditions are there, that I'm switching off. That is nothing but constraints under t underscore h1 dot constraints underscore mode 0. Okay, so if you want to stop the randomization, that rand underscore mode equal to 0, no. So if you want to stop the randomization, that condition constraint means you need to stop this one. So I want to display these values t underscore h1, and after that what happens at t underscore h2, I'm initializing with one more function randomize, and also I want to display this t underscore h2 dot data is percentage d. Okay, so this so whether these randomized functions are coming to this second handle t underscore h2 or not, I want to check. Okay, so how to check means just okay, this file is there, no. So I will see in the tool only. Yeah, so here you see run minus all, not run minus sim quit sim, and what is my function? Vlog underscore. So what function is there? Underscore sv. Okay, this one too. Okay, so vlog tb. Okay, tb underscore static constraints underscore 2 dot sv. Okay, dot sv. Okay, enter. Okay, you got something. Okay, warning. Randomize. Okay, okay. Next, what you need to do? vsim. What is my function? Testbench function. tb static constraints underscore 2. No, so copy this and vsim in this paste this. Okay, vsim and next. So simulation will open and run minus all. Run hyphen all. Okay. So what I am getting here, what happens initially, t underscore h1 data is 7 and t underscore h2 data is 7. Okay. So that randomization is coming to 2 also. Okay. So randomization, that conditions I stopped in t underscore h1, but that conditions you are getting on the handle t underscore h2 also, you are getting that conditions. Okay. That conditions you are getting at t underscore h2. Okay. So like that we can check. Okay. So this is one condition, and next one, third one. If you see the third one here, we see this one. Here what I did means like I given some values, range value. Okay, so ranges between this 0 to 10, and so I want, suppose in this I want to execute these values. Okay, more than 10, whether it is working or not. Just I will see in the EDA playground only. So copy this and I'm opening the EDA playground. Okay, so just paste this. I will check this. Okay, whether I'll select the tool, I'll like to run this. So here, what is my constraint? That is greater than 10 means it is executing. Okay, it is getting to T underscore H2 also you are getting. Okay, and just I will comment this, and I want to check for what less than 10. Okay, less than 10. Okay, less than 10. Just run this. So I'm getting, that means I'm getting that values, random values at a t underscore h1 and t underscore h2 also I'm getting less than 10 only. Okay, towards this. Okay, and if I comment this, I want to execute only these values. Okay, I will see how I am getting. So means first two handles I'm getting, and next handles I'm getting. So that means I stopped this one now. So I stopped this conditional constraints. So that's why I'm getting the random values. Okay, conditional constraints I stopped. So that's why I got random values. So suppose if I keep one, what I will get, we'll see. So that constraints I'm getting, see here, I'm getting the values between 0 to 10. Okay. So suppose this one, if I comment and I want to see whether it is executing or not. Now also it is executing. Okay. So like that. Okay. So when you keep this as a zero means what? You are getting some that conditional constraints. The conditional values you are not getting. You are getting some random values. Okay. So t underscore h1 dot constraints underscore mode 0 you are keeping. So like first two handles you are getting some between this, but after that you are getting some random values. Okay. So like this, you can see the suppose if you keep static before this, what is that static? Okay, static. Okay, so what will happen? We'll see static. Okay, static is a keyword. Okay, mm, static. Okay, if I run this, what I will get? So static means here what I am getting. So t underscore h1 data, t underscore h2 data is 2. After that, t underscore h1 data, you are getting some random value. Okay. Why? Because I given this value, no. So this is 0 I given. Okay. If I give 1 means you are getting same value. So if I give 1, so you are getting the values between this so between these this 0 to 10. Okay. So if it is 0 means you are getting after displaying these values, you are getting some random values. Okay. So why? Because I switched off this randomization, conditional randomization. Okay, conditional randomization I switched off. Okay. So like that you can do this. Okay. And and next is calling the function inside the constraints. Okay. What are these calling the functions inside the constraints? Okay. Mm. So inline constraints also we already seen inline constraints. Okay, in the last class, inline constraints. What are the inline constraints like? Inline constraints. Inline constraints. Okay, t underscore h randomize randomize with this is x greater than y, x greater than y. Okay, this is inline function. Okay, inline constraints. Okay, calling the function inside the constraints, calling the function inside the constraints, inside the constraints. Okay, so what is this calling the function inside the constraints? Suppose if you consider the one example, uh, rand rand int, let us take e underscore addr. Okay, e underscore addr and rand int s underscore addr. Okay, addr. I'm using a function. That means calling a function. No, function function bit 3 down to 0, 3 down to 0, addr underscore calc bit 3 down to 0, addr 3 down to 0, addr. Okay, so if addr is greater than 8, okay, op equal to what? 0. Okay, else op equal to op plus 1, op plus 1 and end function, end function. Okay, here I need to write the constraints. Okay, how I write the constraints? So that means constraint valid underscore address, valid underscore address e underscore addr, that is equal to addr underscore calc uh, s underscore addr. Okay, and close this flower bracket. Okay, so this also, this is assignment 3. You need to write code for assignment 3. Okay, assignment 3. So you need to write the code for this calling the function inside the constraints. Okay, calling the function inside the constraints. Okay, and next is scope randomization. Scope randomization. So what is the scope randomization? Suppose like module test, module test. Okay, and int a comma b, int a comma b, initial initial begin, initial begin. So I am using like std std. This is scope. So this the symbol for scope randomization is 2 colons. Okay, 2 colons. Okay, so this is nothing but what? Scope resolution operator. This is scope resolution operator, scope resolution operator. Okay, so here randomize a comma b with a greater than 10 and a less than 20, and here, okay, one second. Here, no closing of this bracket. B greater than 10, b greater than 10 and b less than 20, b less than 20. Okay. So for this also you need to write the program. This is assignment 4. Assignment 4. Okay. Assignment 4. Okay. So here, so if you see the conclusion, so what is my conclusion? We seen the randomize. What is randomize? Randomize is nothing but a virtual method. We can't override, and constraints can be inherited. Okay, inherited means we already seen the constraints within the parent class and child class. Okay, we use the same constraints. You need to use. So if you are using same constraints, you need to use a soft keyword or inline function. Inline constraints also we see. Okay, these constraints are very important. Okay, in the SV. Okay, just you need to go about this. Okay, so I think you understood the assignment. So assignment, this is assignment. This one, distributed constraints. You need to write the program for distributed constraints, and assignment 2 is you need to write for conditional constraints. Okay, conditional constraints, and assignment 3 is calling the function inside the constraints. You need to write the code, SV code for this one, and you need to write the code for scope also, scope randomization also. You need to write the code. Okay, so just you need to write this code. Okay. Yes, one second. Okay.